What's up, everybody? This is Daniel Mathematics again, and today I want to go over example 2 of how to solve systems of equations using the substitution method, okay? And the only objective when we're dealing with systems of equations is for us to find out the value of x and the value of y that makes this system of equations true, okay? So we have this system right here. I have these two equations. The first equations, and I'm going to label that as equation number 1. I'm just gonna put a 1 by it, or you can put an A or B by it, whatever. The first equation is y equals 3x plus 2. The second equation is y equals 7x minus 6, okay? So what we're going to do is, the first step we're gonna do is, we're going to use the value of y, or the expression that equals y, and we're going to substitute that as y of the second equation, okay? So what we're going to do is we're going to substitute for y to solve for x. Once again, we're going to substitute for the y variable, and we're going to solve for the x variable, okay? Now, as you can see, right, the first equation says that 3x plus 2 equals y. The second equation says that 7x minus 6 equals y, right? So if that's the case, what we can do is we can use this whole first equation, right, or the expression part of the first equation, which is the 3x plus 2, and we can plug that in as the y that's in the second equation, okay? So once again, since y equals 3x plus 2, and then y also equals 7x minus 6, we can plug in the 3x plus 2 as the y of the second equation, okay? So let's actually do that. So I'm just gonna rewrite the second equation because I just wanna show you what I'm doing. The second equation is, once again, is y equals 7x minus 6, y equals 7x minus 6. And once again, I'm going to plug in the first equation as y, because the first equation, or the first expression, actually equals y, right? So I'm going to plug that in as y. So that y becomes 3x plus 2 equals 7x minus 6, okay? So far we have successfully substituted for y, right? And then we have set it up to where we can actually solve for x. Remember, whenever you're solving for variables, right? Values of variables, we can only do it one at a time. We can't solve for x and y at the same time. We got to either eliminate one or substitute one to solve for the other, okay? So now I have this expression, 3x plus 2 equals 7x minus 6. Now, here's what I teach my kids, my students. I tell them to go ahead and to label one side as the relationship side, and you can label the other side as the single side. So for the relationship side, I like to put a heart, and the single side, I just put the word single. Now, what I mean by single is the singles are just the numbers that are not attached to a variable, all right? The relationships are the coefficients and the variables that are attached to one another, right? That's why I call it a relationship, because they're holding hands. Look at it like that. So 3 and x are in a relationship because they are attached. 7 and x are in a relationship because they are attached. 2 is single because it's not attached to a variable or s. So I'm gonna put, or x. So I'm gonna put an s underneath. And the same thing with -6. It's not attached to an x or a variable. All right. So once again, our objective is to move all the relationships on the relationship side and move all the singles on the single side, right? Since 2 is single, I got to move it over there, right? So in order for me to do that, I got to subtract 2 on both sides. Subtract 2 on both sides, right? And 7x is in the relationship, right? So what I'm going to need to do is I'm going to have to subtract 7x on both sides in order for me to move 7x to the relationship side. Okay? So on the relationship side, I have 3x minus 7x, which is a negative 4x. Equals, of course, that cancels out. I have a negative 6 and a negative 2, which equals a negative 8. So now I have negative 4x equals negative 8. In order for us to find out the value of x, we got to divide both sides by the coefficient, which I call it the breakup, right? They got to break up. The relationship is over. So I got to divide both sides by negative 4. Negative 8 divided by negative 4 is a positive 2. So we know so far that x equals a positive 2. So since x equals a positive 2, what we're going to do is step 2, which is plug in the value of x to find the value of y. All right, once again, we're going to plug in the value of x inside of one of, or if not both equations, to find out the value of y, okay? So I'm just going to simply choose the first equation number 1, which is y equals 3x plus 2. Once again, we know that the value of x is 2, so what we're going to do is we're going to rewrite it and we're going to actually substitute x as 2, right? We're going to actually put the value of the x variable, okay? So now I have 3 times 2, which is 6, and then 6 plus 2 is 8. So that equals 8. All of that equals 8, which means that y equals 8. So the value of y is 8. Now, we can check one more time just to make sure that we do have both values that are correct. We can also plug in both values in the second equation. So I'm going to do that with the second equation. I have y equals 7x minus 6. Once again, we have the value of y, which is 8. So for y, I'm going to substitute that and put 8. And then we have the value of x, which is 2. So instead of 7x, it's going to be 7 times 2, right? Minus 6. Okay? 7 times 2 is 14. 14 minus 6 is 8. Right? And then we know that 8 equals 8, right? So that lets you know that these two values make the system of equations true. And this is how we can solve systems of equations using the substitution method. Okay? Thank y'all so much for tuning in. I will talk to you next time.